Many engineers, even many people who have been practicing for many years, engineers for more than a decade or two there will be a common problem everywhere. How do we choose benchmarks? We have various benchmarks. We use a lot of benchmarks. There are our design benchmarks. Okay? There are machining benchmarks for our parts. There is an assembly benchmark for our assembly. The cooperation mechanism that our male and female complement each other. And our products are in the process of application. The application technology that it really realizes the function. That's all we have for our entire product. That's 5 benchmarks. I use design benchmarks. Or is it based on processing? For example, we have a lot of terminals. There are many pieces. It's in the process of machining. Machined rotating body. It's involuntary. It will be based on its center of rotation. This is caused by the characteristics of processing, due to special characteristics. For example, some of them are flaky. For example, what does this gold metal sheet look like? They are in the process of processing. It must be the largest by area. The faces that are easiest to position serve as a reference. This is its processing characteristics. But a lot of times, its processing characteristics do not meet my design requirements. At this time, what about my design benchmarks and machining benchmarks? Conflict with each other. Who is the main one, right? There's one more thing. It's our design benchmark. Basically, some theoretical benchmarks. Let's say we have some symmetrical features, or some feature of rotational symmetry, or something that can be arrayed. In the case of, then these benchmarks and our assembly. The actual assembly is different. We may have one for actual assembly, assembly reference point, or pretend, fixing point. That matches our design benchmarks when they can't be combined. So what do we do with this benchmark? How to choose this priority? And here it is, based on years of personal experience. According to my understanding of this industry, first of all, our design benchmarks come from applications. It must be the other way around. Why did you draw this picture just now? All our designs come from apps. So my design benchmark must be anchored. It's benchmarking. Okay, so my design benchmark is number 1. That's why Amphenol. T1. One of the fundamental reasons why they focus on design. That's good. My design benchmarks come first. During the design process, we need to consider processing and assembly, the most basic and lowest level. All my parts all require a processing process. So in the case of first principles, I will consider processing technology. The best. Of course, let my machining benchmark can overlap with my design benchmarks when there is really no way to overlap. Okay, let's focus on design benchmarks. Secondary consideration of machining benchmarks. So it takes precedence over it. When the machining benchmarks cannot be aligned, there will be something called the benchmark error. Baseline tolerances. This benchmark tolerance allows. In fact, it is the machining accuracy of my machining. We all hope that our products can achieve the desired level. Design theory value. Design theoretical value. So what happens when the two benchmarks don't coincide? Injection molded parts we know plus or minus 0.02 or plus or minus 0.015. I wouldn't settle for plus or minus 0.0005, would I? Because of its base. Its machining accuracy basis difference cannot be reached. But the stamping parts, no. We can all do plus or minus 0.11. The same principle. When my machining accuracy is determined, let's think about our assembly again. This assembly is an assembly between existing parts. There is also this assembly between parts and components. Then consider my cooperation. Of course, in the end, it comes back to the application. Then this application follows this closed-loop logic. It actually comes back to what we designed, because all my designs are application-specific. That's it. How do we define in this process? We often see, in some products, when there are some special quality problems, often we have some mold-making engineers, or say some of our mold suppliers say, hey, your product design is wrong. My mold processing is processed like this. Why would you design like that? In theory, it's not supposed to be that way. It should be said that it is my product design. Your mold is not done according to my product design. Certainly, it depends on how we measure this design benchmark. Control yourself well or not. And this logic throughout our entire production of connectors and wiring harnesses, manufacturing application, and the whole process of design. That piece. We need this technician and our R&D staff. It is necessary to have such a concept. Certainly, this doesn't necessarily mean it is the most suitable. It's not necessarily the best fit. Under certain special circumstances, in the case of certain specific applications, it is likely that my cooperation benchmark or my equipment benchmark, especially in automation applications, very, very broad areas. Ours has some assembly time because it needs to be positioned, because it needs to be done visually. For some reason, it's equipped with baseline requirements. It may exceed my processing. Maybe I need my design too. Make some corresponding adjustments. This is indeed there. For example, we are now in the production process. It's all vision robots and manipulators. The robot and the manipulator. It needs to be positioned. Very likely. In our original product design process, we think very uncritical, or where there is no need for benchmarks. Because there are robots, there is automation. He needs to locate. He needs to benchmark. And that creates some additional benchmarks at this point in time. That's another story. Okay, thank you.